Hello and welcome to day 11 of Calculus in a Year. Today, we're going to do some limits practice. And this will be the first of two videos for practicing limits, just for limit practice problems. So, here's the plan for finding limits. First, see if you can just plug in the limit value. So, just plug in the limit value into the variable. And note that if the function is a constant, then that constant is going to be your answer. And I've written it down here. The limit as x approaches some number, and the function is a constant. So if you have the limit of a constant as x approaches some number, the answer will just be that constant. So if I were to have the limit as x approaches 100 of 4, this would just be equal to 4. So just remember that. And plan B. If plugging in doesn't work, then see if you can simplify or change the function in such a way so as to be able to get a real number for your limit value. So just try to see if you can simplify it or change the function somehow such that you can get a real number as your answer. And note that this plan does not work for piecewise functions, and piecewise functions are those that look like this. So this plan won't work for that, but you're going to rarely encounter these, so don't worry too much about that. And so let's go on to the first problem. Find the limit as x approaches 5 of 2x minus 10 over x minus 5. So I would encourage you to pause the video and try this out on your own. Alright, so if you try plugging in, you'll realize that that's not going to work because if you plug in 5 for x, you're going to get a 0 in the denominator, and so you won't have a real number as your limit. So let's try an alternative method. If you try to simplify it, then you can factor out a x minus 5 term, and then these will cancel. So we have this 2x minus 10, and we can factor that into 2 times x minus 5. And the x minus 5 terms will cancel, and we're just left with 2. And then the limit as x approaches 5 of 2 will just be 2. Let's move on to the next problem. Find the limit as x approaches 8 of 4x over x minus 7. Once again, please pause the video and try this out on your own. Alright, so first of all, try plugging in, and you'll realize that that works. We get a limit value of 32, and so that's our answer. Now for the next problem, find the limit as x approaches 12 of 1 over tangent x. So once again, pause the video, try this out on your own. Alright, now if you try plugging in, you'll see that you get a real number as your answer, and so this is your limit. And here's just one quick challenge problem that I'll give you. Find the limit as x approaches 0 of 1 over cosine x. So pause the video and try that out on your own. Alright, so you can actually just plug right in. You'll get 1 over cosine of 0. This was equal to 1 over 1, which is just 1. So that's your answer for that. And here are some trig functions, some trig limits involving trig functions that you can note down. So the limit as x approaches 0 of sine x over x is going to be equal to 1, and the limit as x approaches 0 of tan x over x is going to be also equal to 1. And a little later in our calculus journey, we'll learn something called L'Hopital's rule, and that'll help us find these sorts of limits. And so that's it for today. Thank you for watching, and I hope to see you back soon.